Hello my dear viewers and also my fellow students. So you are much welcome to this mathematics paper 1 KCSE 2023. So I've done section 1 from question 1 all the way to 16. So if you haven't subscribed, can you please remember to subscribe and also share to your friends and colleagues. So thank you so much as you stay tuned to the end. Welcome. Begin with question 1. And in question 1, without using a calculator, evaluate minus 13 plus 5 minus 70 divided by 5 all over 9 minus 14 times minus 3 divided by 21. So from this question we have the numerator and also we have the denominator. So I'm going to work out the numerator first. We work out the numerator and then we later work out the denominator, then we combine the evaluation. So the numerator we have minus 13 plus 5 minus 70 divided by 5. So in our case we are going to use body mass. So body mass, which is so important, which means bracket of division, multiplication, addition, subtraction. So in this case there is no bracket, there is no off, there is division. So in our case we are going to divide. That is the first calculation operation we are going to do. Minus 7 divided by 5. So we have minus 13 plus 5 minus 7 divided 5 minus 70 divided by 5, we get minus 14. Remember, it is a negative divided by a positive number, so minus 14. So the next operation will be multiplication. There is no multiplication, we have addition and subtraction. So for addition and subtraction they are commutative, so we can start with either. So for this I can take minus 13 minus 14 plus 5. Minus 13 minus 14, that is minus 27, then plus 5, we end up getting minus 22. Then we look at the denominator part. For the denominator part, we have 9 minus 14 times minus 3 divided by 21. We do the same way. There is no bracket, there is no off, there is division. So we are going to deal with the division for operation first. So 9 minus 14, then times minus 3 divided by 21, so that will be minus 1 over 7. Then from there the next operation is multiplication. Therefore this case we have this operation, so by 7 1 by 7 2, so minus 2 times minus 1, that is plus 2. Therefore we shall have 9 plus 2, we end up getting 11. So the last part we do is now we combine the numerator, we divide by the denominator, and the numerator is minus 22, denominator is 11. So if we divide, we get minus 2. So that is question 1. We move on to question 2. Question 2, simplify the expression. We have 3a squared times b raised to minus 3 all over 2 raised to minus 1 times a raised to minus 2 times b raised to 2. The same way, let us work out the numerator and then we work out the denominator. So for the numerator, we have 3a squared times b raised to minus 3. Remember the laws of indices. So for this case can be written as 3a squared all over b raised to positive 3. And then for the denominator, whereby we have 2 raised to minus 1 times a raised to minus 2 times b raised to 2. 2 raised to minus 1 can be written as a half times 1 over a squared times b squared. So this is the same as b squared all over 2a squared. Therefore, if we take the numerator, we divide by the denominator. So this will be 3a squared all over b raised to 3 divided by b squared. The denominator is b squared all over 2a squared. So this is the same as 3a squared all over b cubed times the reciprocal, which is 2a squared all over b squared. So for this case, we multiply the numerators. 3 times 2, that is 6. A squared times a squared, that is a raised to 4. We add the powers. And the denominator part is b raised to 5. We add the power since the base is the same. So this can also be written as 6 a raised to 4 times a raised to, b raised to minus 5. So either of these is acceptable. Then we move on to question 3. A triangle ABC is such that AB is equal to 11 centimeter, BC is equal to 8 centimeter, and angle ABC is equal to 53 degrees. Calculate the area of the triangle correct to 2 decimal places. So for this question, let me just sketch the triangle. Since a triangle, just make a sketch of it. So triangle A, B, C. So side AB is 11 centimeter, and then BC is 8 centimeter, and angle ABC, this is the angle, it is 53 degrees. So we need to calculate the area of the triangle correct to 2 decimal places. So we know there are different formulas for calculating the area of a triangle, but which one will be more applicable? For this one, the area will be given by a half times 2 sides AB times sine theta, where theta, so it's actually the angle between the two known sides. So for this case, we have a half times A will be 11 centimeter times B will be 8 times sine theta, theta will be 53 degrees. So therefore, a half times 11 times 8, that is 44, times sine 53 using calculator will be 0.7986 to 4 significant figure. So if we multiply by 44, we get 35.1384 centimeter squared. But the question requires to 2 decimal places. So to 2 decimal places will be 35.14 centimeter squared, and that is to 2 decimal places. So that is the area of the triangle. We move on to question 4. A cylindrical solid of radius 7 centimeter has a conical top of the same radius. The height of the cylindrical part of the solid is 17 centimeter. The conical top has a vertical height of 9 centimeter. Calculate the volume of the solid. We take pi as 22/7. This is 3 marks. So the first thing I'm going to do is just to make a sketch of that particular solid. So it has a conical top. So this is the cylindrical part, and then it has a conical top. Therefore, the information given, it has a radius. So the radius is 7 centimeter. That is 7 centimeter. That is the radius. And also the height of the cylindrical part is 17. So this height is 17 centimeter. And the conical top has a vertical height. The vertical height of 9 centimeter. Calculate the volume of the solid. So to get the volume of the solid, we need to get the volume of the cylindrical part plus the volume of the conical part. So the volume of the cylindrical part, volume of cylindrical part will be given by pi r squared times height. So in our case, I will consider this as the height 1 and the other one as the height 2 to make it clear. So for this will be 22 over 7 times radius is 7 squared times height, which is 17 centimeter. So using a calculator, we end up getting 2618 centimeter cube, and then volume of conical part will be given by a third pi r squared times height. So a third times the base area times height. So for this case, we have a third times pi is 22 over 7 times r is 7 squared, so times height of the conical part is 9 centimeter. So using a calculator, we end up getting 462 centimeter cube. So volume of the solid will be the sum, and the volume of the cylindrical part, which is 2618, plus the volume of the conical part, which is 462. So here we add it together, we get 3080 centimeter cube, and that is the volume of the solid. We move on to the question number 5. Two light bulbs are set to light after every 40 seconds and 60 seconds respectively. If they light exactly at the same time initially, calculate the time in minutes they will take to light together again. And part B, the number of times they would light together in the first half an hour. So, part A of the question, the time in minutes they will take to light together. So in this situation, we can see that the first one light after 40 seconds, the next one light after 60 seconds. So we are required to find the LCM of 40 and 60. So to get the prime factors of 40, it will be 2 raised to 3 times 5. And the prime factors of 60, it is 2 raised to 2 times 3 times 5. So to get LCM, of 40 and 60, we are required to find the factors with the highest power. Factors with the highest power. So in this, we have 2 raised to 3. Then we also have 3. And also there is 5 again. So, in other words, it will be 2 raised to 3 times 3 times 5, which is 120 seconds. 120 seconds is actually equal to 2 minutes, because 1 minute is 60 seconds, so which is 2 minutes. So in other words, they are going to light together after 2 minutes, that is after 120 seconds. Then, part B of the question, the number of times they would light together in the first half an hour. In 30 minutes, the number of times they are going to light together. So actually they are lighting together after every 2 minutes. So after 30 minutes, therefore it is 30 divided by 2, the period after which they light together. So we get 15 times. We move on to question number 6. Solve the equation cosine 2 theta is equal to sine theta for 0 radians is less or equal to theta is less or equal to pi over 4 radians, and we leave the answer in terms of pi radians. So in this situation, I want you to remember about complementary angles. We say there are angles that add up to 90 degrees. Therefore, cosine 2 theta is equal to sine theta. So here we have complementary angles. In other words, 2 theta plus theta will add up to 90 degrees. So this is 3 theta will be equal to 90 degrees. Therefore, divide by 3, divide by 3. We get 30 degrees. Therefore, theta is equal to 30 degrees. So we need to convert this to pi radians. We know that 2 pi radians is equal to 360 degrees. What about 30 degrees will be equal to what? So let's say x. So that will be equal to 30 over 360 times 2 pi radians. 12 by 2, 1 by 2, 6. Therefore, we have pi over 6 radians. Question 7. Simplify and hence factorize the expression 5x minus 4y into bracket times 4x plus 5y into bracket minus 9xy. So let me just rewrite the expression 5x minus 4y to bracket multiplied by 4x plus 5y into bracket minus 9xy. So we needed to expand by opening the brackets. So I have 5x multiplied by what is in the second bracket, which is 4x plus 5y is a bracket, then minus 4y multiplied by 4x plus 5y into bracket, then minus 9xy. So opening the bracket, 5x times 4x, that is 20x squared, then plus 5x times 5y, that is 25xy, then 4y times 4x, that is minus 16xy, then minus 4y times 5y, that is minus 20y squared, and then minus 9xy. Then collect the like terms, minus 25x min plus 25xy minus 16xy, that is 9xy, then minus 9xy, that will be 0. Therefore we remain with 20x squared minus 20y squared. We can factor out 20, which is common, so we have 20 into bracket x squared minus y squared. So remember difference between two square. If you have a squared minus b squared, it can be written as a plus b into bracket times a minus b into bracket. So this is so important. So we can express this as 20 times x plus y into bracket times x minus y. And therefore we have simplified and we have factorized it completely. So we move on to question 8. From a point on top of a cliff 40 meters high, two boats A and B are observed due east. The angle of depression of boat A is 32 degrees and that of boat B is 52 degrees. Determine the distance between the two boats correct to 2 decimal places. So the first thing we need to start, let us draw the sketch to show the position of the boats and also the cliff. So if this is a cliff and which is 40 meters high, is the top of the cliff and you have the foot of the cliff. So the boats are due east, so this direction. So the angle of depression of A is 32. So from the top the cliff, so this is normally the angle of depression 32, so it will be equal to the angle of elevation 32. So A is 32 degrees, the angle of depression from the top of the cliff, and that of B is 52. So B is at that particular point, so all of this angle will be 52, therefore angle of elevation will be 52 degrees also. So from the foot of the cliff, we let this distance bx and of B from the foot bx meters and AB y meters from the foot of the cliff. Therefore, using trigonometric ratio, we have SOHCAHTOA. In our case, we know the opposite, and also we have the adjacent, and we have the angle. So we are going to use tangent is opposite over adjacent. So tan 52 degrees will be equal to opposite, which is 40 divided by x, and therefore x will be 40 over tan 52 degrees, which is actually equal to 31.25 meters. Then the other one is, now we have 32, 40 and y, so tan 32 degrees will be equal to 40 over y. Therefore y will be equal to 40 over tan 32 degrees. Using a calculator, should end up getting 64.01 meters. Therefore, to get the distance between A and B, distance between A and B will be y minus x, and that will be 64.01 minus 31.25. So we end up getting 32.76 meters. And that is the distance between the two boats A and B. Next, we move to question 9. So for question 9, it's a triangle ABC, which is a uniform cross section of solid ABCDEF. Given that BC is one of the edges of the solid, complete the sketch showing hidden edges with broken line. So, from common solids we have learned about isometric projection, oblique projection and perspective projection. So this is very important when drawing solids. Now, the first thing we need to know, the part which is seen clearly we draw with complete line, but the part which is hidden, it is drawn using broken lines. So for this case, we want to join C to D, therefore C to D must be parallel to BE, and since it is the part which can be seen, in that case we'll be using a ruler. We are going to draw a straight line which is parallel to BE, and we call it D. Then we join E to D, which is parallel to BC, but in this case is actually hidden, so we draw using broken line, like that. The other case is to locate the vertex F, and vertex F, which will be parallel to BE and also DE. So from A, and this will be drawn using complete line, like that. And then from F we draw F to D, which is also seen, so complete line, but F to E using dotted line. And that's how we have drawn solid. Now is complete. You can actually do it by construction using compass and ruler, drawing the dimension correctly. So move on. Question 10. A salesman sells a storybook and textbooks. The cost price of a storybook is 600 shillings, while that of a textbook is 900 shillings. The salesman is paid a commission of 10% on the cost of any book sold. One day, the salesman sold twice as many storybooks as textbooks. He earned a commission of 8,400 shillings. Determine the total number of storybooks sold. So from here, we sold storybooks and also textbooks. So cost price of a storybook was 600 shillings. That of a textbook was 900. And then he gets that this commission on the cost of any book sold. So if that day salesman sold twice as many storybooks as textbooks, so the storybook sold was twice that of textbook. So we can say let the number of textbooks sold be T. Therefore, number of storybooks will be twice storybooks. Will be twice that of textbooks. So that will be 2T. Total cost. Been given the total cost price for textbooks was 900. Therefore, the total cost for textbooks will be 900 times T. That means for a textbook was 900. So for T textbooks, it will be 900 times T. Then plus the total cost of the storybooks. One storybook was at 600, so it will be 600 times 2T. So this will be 900 T plus 600 times 2T, that is 1200 T. So we end up getting 2100 T shillings. Therefore, the salesman is paid a commission of 10% on the total cost of any book sold. So in this case, he'll get 10% of 2100 T shillings. And in this, it's actually even that time he sold the books, he got a commission of 8,400. Therefore, that was the 10% of what the total cost it sold. So this will be 10 over 100 times 100 T, which is equal to 8400. So T will be equal to 8400 times 100 divided by 10 times 2100. So if we divide 0 and 0 will cancel, 0 and 0 will cancel, by 7, 3, by 7, 1, 2, 0, and by 3, 1, by 3, 40. So T is equal to 40. Therefore, have we answered the question? The total number of storybooks. So the number of storybooks sold will be equal to, that is 2T, and therefore 2 times 40. So there were 80 storybooks sold. Move on to question number 11. The equation of a curve is given by y is equals x squared. Using the trapezium rule with 4 strips, estimate the area enclosed by the curve y is equal x squared. The lines x is equal to 1, x is equal to 5, and the x-axis. So in this case, we have the curve y is equals x squared. So in normal practice, If the curve was to be drawn, it has this kind of a shape through the origin, y is equals x squared, and therefore we require from x is equal to 1, so 0, 1, 2, 3, 4, 5. So that's what we are required to have. And how many strips? 4 strips. So we have the first. So we have 1, 2, 3, 4. The 4 strips. Therefore, the width is normally given by 5 minus, this will be 5 minus 1, the range divided by the number of strips, 4. So we have 1. So the width will be 1. Therefore, something else that we need to have. Now we have the 4 trapezium. So we need to get this height y0, y1, y2, y3, and y4. So let us make a table x for the corresponding values of x and y. So when x is 1, 2, 3, 4, 5, what is the value of y? So what will be the value of y? So in that case, we should have y0, y1, y2, y3, y4. So what is actually the values? So when x is 1, y will be what? So we actually substitute into this equation, y is equals x squared. So when x is 1, y is also 1. When x is 2, y is 2 squared, 4. When x is 3, y is 3 squared, which is 9. When x is 4, y3 will be 16. Then when x is 5, y4 will be 25. Therefore, the area is given by a half. To bracket, we have then y0 plus y4. Those are the extremes. Height plus 2 to bracket y1 plus y2 plus y3. Close the bracket. Then we close the square bracket. Then we substitute into. So we shall have a half, then the square bracket, then we have y0 is 1 plus y4 is 25, close the bracket, then plus twice the sum of the other heights, y1 is 4 plus y2 is 9 plus y3 is 16. Therefore, this will be a half, and times 1 plus 25, that is 26, then plus 2 to bracket 4 plus 9 plus 16, that is 29. Therefore, this is a half. Now this will be 26 plus 2 times 29, 58. So we shall have a half of 26 plus 54, that is 58, that is 84. Then a half of 84, that will be 42 square units, since we are looking for the area enclosed by the curve, the x-axis. So that is it. So we have the x-axis, the curve, and x is equal to 1 and x is equal to 5. So that part, we'll find the area. So the next question, 12, vectors A, B, and C are represented on the following grid. So the question is, on the following grid, represent the resultant vector A plus B. So for A plus B, how do we get A plus B? Just to redraw, we have A from this particular point, that is vector A, then B is actually, so for B will be from where we have A, so we have B vector. So to get plus B, now we can move directly from this point to B. So this is the vector, that is A vector plus B vector. So that is part A. Then for part B, whereby now we need the resultant vector A plus B into bracket plus C. Now, from what we have been given, we can see vector C move from the top left to the bottom right. That means there is a movement in the X direction, 2 steps, in the Y direction, 2 steps downwards, and therefore, from what we have here, we shall have the combined, so part B, so AB from this point, and then it has actually moved 3 steps to the x-axis and y 3 steps upward in the y. So from this point to this point, that is the A plus B. Then C is downward, so this is the direction up to this particular point, C vector. Therefore, to get the resultant vector, it will be from this point to this point, which will be A plus B vector, then plus C vector. Hope that is clear. So that's how we are supposed to answer that particular question. We get the resultant vector in that manner. Then question 13. Given matrix P, which is 4, 2, minus 7, minus 1, then matrix Q, minus 1, 5, 6, minus 3, and R is equal to 20, the inverse of P plus Q. Determine matrix R. So the first thing we need to get, we need to find R is equal to 20 inverse of P plus Q. So we need to get the inverse of matrix P. In that case, we need first to get the determinant of matrix P, and that will be given by, we'll get by multiplying the elements in the main diagonal. 4 times minus 1, that is minus 4, then minus the product of the other diagonal, minus 7 times 2, that is minus 14. So this will be minus 4 plus 14, which is 10. Therefore, to get P inverse will be 1 over the determinant, which is 10, and then we interchange the elements in the main diagonal, we interchange the position. So 4 we shall have minus 1, where we have minus 1 we shall have 4. Then we interchange the signs of the other diagonal such that we shall have minus 7 will be 7 and 2 will be minus 2. Therefore, R will be equal to 20 times the inverse of P, which is 1 over 10 divided by minus 1, 2, minus 2, 7, 4, then plus Q is minus 1, 5, 6 minus 3. This will be equal to 20 times 1 over 10. So by 10, 1 by 10, 2. Therefore this will be 2. Then we have minus 1 minus 2, 7, 4, multiplied by plus, minus 1, 5, 6, minus 3. So the next, just open the bracket, is multiply this scalar times the element in the bracket. So this will be minus 2, then minus 4, then 2 times 7, 14, then 2 times 4, which is 8, then plus, minus 1, 5, 6, minus 3. So then we add corresponding elements. We added the corresponding elements, and that will be, R will be equal to corresponding elements minus 2 and minus 1, they correspond, minus 2 plus minus 1, then minus 4 plus 5, then you have 14 and 6, they correspond, we add them, then 8 and minus 3, 8 plus minus 3. So R will be, therefore we have minus 3, then we have 1, 20, and then this is 5. So that is the matrix R. Next, question 14. In a sub-county, the number of children per family was recorded from 30 families. The data recorded is as follows. So this is the data recorded. So part A, we represent the data in a frequency distribution table, and also we calculate the mean number of children per family. So, represent the data in a frequency distribution table. So we need to have the number of children, then the tally, then the frequency, and since this part requires us to find the mean number of the children. So the least number of children is 0, then there is 1, there is 2, you have 3, up to 7, 4, it's 5, 6, and 7. So the least number of children is 0, the highest number of children is 7. So we're just using to tally so that we don't mess up. So we can start, we have 2, put a tick, it's a 2, another tick, we have 6, tick, 3, put a tick, 2, there are 2, so we put those ticks. There's another 2, tick, 1, tick, 2, a tick, 3, 3 times, 1, 2, 3, then we have 4 times, 1, 2, we have 3, another tick, 1, a tick, 5, a tick, 3, a tick, 4, a tick, 2, a tick, 5, a tick, 3, a tick, 7, a tick, 1, a tick, 0, a tick, 6, a tick, 3, a tick, 3, a tick, another 3, a tick, then lastly 2, tick. Therefore we count them and to get the frequency. So that is 1, there are 3, there we have 8, it is 10, it is 3, we have 2, 2, and this is 1. If you add all of them, you count all of them, that is 30. Now, something else is to get now the calculate mean of the children per family. Remember, for frequency distribution table is up to this particular point. Now, from here, we need to get the mean, and to get the mean is by getting the sum of fx divided by sum of f, or the number of families. So sigma fx, that is gotten by, this is our x, so 0 times 1, that is 0, 1 times 3, 3, 2 times 8, 16, 3 times 10, 30, 4 times 3, 12, 5 times 2, 10, 6 times 2, 12, and 7 times 1, 7. So if we add all the totals, we should be able to get 90. Therefore the mean will be sum of fx, which is 90, divided by sum of f, which is 30. So the mean number of children in a family is 3 children. Then question 15. The equation of a curve is given by y is equal to 3x squared minus 2x. Determine the equation of a normal to the curve at x is equal to. So for this case, we have to get the value of y when x is 2. So that is the first thing. So that we get the point and the coordinates of the point at that particular point where it is normal to the curve. So at x is equal to 2, therefore y will be 3x squared minus 2x. We substitute the value of x. This will be 3 times 2 squared minus 2 times 2. This is 3 times 4, 12 minus. So y will be equal to 8. So that's at the point 2, 8. Therefore, we need to determine the equation of the normal. And in that case, what will be the gradient function at the 0.28, a gradient function. So dy dx will be given by, so we differentiate this equation given. So we shall have differentiating y with respect to x, that will be 6x minus 2. So at x is equal to 2, therefore gradient function will be 6 times 2 minus 2, which is 12 minus, which is 10. So gradient of normal will be, remember the product of the gradient at normal line and that of the curve will be equal to 1. Therefore, the other one will be minus 1 times 1 over 10. So which will be minus 1 over 10. So let a point xy, since we want to get the equation of the normal, let a point xy be on line with, so remember the normal, the coordinate is 2, 8. So let them be in line with this point 2, 8. And the gradient of the normal is minus 1 over 10. Therefore the equation will be given by change over y over change in y over change in x will be equal to this value. So y minus 8 all over x minus 2 will be equal to minus 1 over 10. Cross multiply, we shall have open the bracket, this will be 10y minus 80 will be equal to minus x plus 2. So we can rearrange this, will be 10y will be equal to minus x. Take minus 80 to the right hand side will be plus 80, that will be plus 82. Therefore y is equals to minus 1 over 10x plus 82 over 10, which is actually 41 over 5, or y is equal to minus 1 over 10x plus 41 over 5. Or simply in another way, if you write this way, x plus 10y minus 82 is equal to 0 will also be accepted. So either of these is accepted. Question 16. On the following Cartesian plane provided, solve the simultaneous equations. So you have the simultaneous equation and you need to plot the linear equation on this Cartesian plane. So the point of intersection, that will be the solution for value of x and y. So now we have the first equation, so we need to make a table for corresponding values of x and also y. So from here we find the value of when x is minus 3 and also, or when x is 0 and also 3. At least 3 points whereby we are going to plot this linear equation. So when x is minus 3, so 4 over 3 times minus 3, that is actually minus 4 plus 2, we get minus 2. Then when x is 0, so y will be 2. When x is 3, 4 over 3 times 3, we get 4 plus 2, that is 6. So that's what we are going to plot. For the other equation, 3y is equals to x minus 3. So this is the same as y is equals x minus 3 all over 3. So we also get values for the corresponding values of x and y. Make a table. Get points near the origin values of x. Since this is over 3, we get values of x which will be divisible by 3. So one of them is, we can have 0. As we can see from the Cartesian plane, we have already been given the values, x-axis and y-axis. So we can also have 3 and 6. So 0 minus 3, that is minus 3 divided by 3, that is minus 1. Then 3 minus 3, 0 divided by 3 is 0. When x is 6, 6 minus 3, that is 3, divided by 3, 1. So we begin by plotting the values for the first equation. So for the first equation, when x is minus 3, y is minus 2. So this is the point here. Then when x is 0, y is 2. This is the point. And then when x is 3, y is 6. That is the point. Therefore, we use a ruler and we join the points. So let us use a ruler and then we join the points. So join the points. So this is y is equals to 4 over 3x plus 2. Then we have the other equation. So when x is, we plot the other equation. When x is 0, y is minus 1. When x is 0, y is minus 1. That point. When x is 3, y is 0. This is the point. And when x is 6, y is 1. Also, we use a ruler to join the points. So we use a ruler to join the points. So this is the equation 3y is equal to x minus 3. Now to solve the simultaneous equation, so this is the point of intersection. So point of intersection give us the solution, the graph, and that is the value of x is minus 3 and y is minus 2. Therefore, x is equal to minus 3 and y is equal to minus 2. So that is the solution. So hello my dear viewers, I'm glad now I've brought to you section 2 of Mathematics Paper 1 KCSE 2023. So section 2 from question 17 all the way to question 24. So stay tuned to the end. And please, if you haven't subscribed, consider to subscribe, share to your friends and colleagues. Also remember to drop your comments on the description below. Thank you so much as you stay tuned. Begin with question 17, and question 17 reads: two towns A and B are 400 kilometers apart. A motorcyclist traveling at an average speed of 60 km per hour left town A for town B at 1:20 p.m. A matatu traveling at an average speed of 80 km per hour left town A for town B at 2:00 p.m. Calculate the distance covered by the motorcyclist by 2 p.m. Roman 2, distance from A in kilometer where the matatu caught up with the motorcyclist. And Roman 3, time when the matatu caught up with the motorcyclist. And part B of question 17, a lorry traveling at an average speed of 40 km per hour left town B for town A at 2 p.m. Determine the time when the lorry and the matatu met. So part of the question, we need to calculate the distance covered by the motorcyclist by 2 p.m. So we have two towns, from town A to town B. So, and it is 400 km apart. So a motorcyclist traveling at an average speed. So we have a motorist, cyclist. So it's traveling from A to B and the speed is 60 km per hour. And also left an A for turn B at 1:20. So the time the motorist left, it was at 1:20 p.m. Then also a matatu traveling at an average speed. We also have a matatu which is also moving from A to town B. So the speed is 80 km per hour and left for turn B at 2 p.m. So that is the time the matatu left. So part of the question, so calculate the distance covered by the motorcyclist by 2 p.m. So we need to know that from 2 p.m. and 1:20 p.m. the difference in time is actually 40 minutes. So 40 minutes, but this is the same as 40 over 60 hours, a fraction of hour. Then, so the distance covered, so the distance covered in 40 minutes, we know the speed of the motorist. So the distance is given by speed times time. So the speed of the motorcyclist is 60 km per hour, and the time, so you have to give the use the time in hours, so that will be 40 over 60 hours. So by 61, so the time will be so we end up getting 40 kilometers. So that is the distance covered by the motorcyclist by 2 p.m. Then part B, part A of Roman 2, distance from town A in kilometer where the matatu caught up with the motorcyclist. That is distance from town A in kilometer where the matatu caught up with the motorcyclist. cyclist. Now, what I want you to note is that from town A to town B. So what is the difference in time or difference in kilometer from where the matatu? So by 2 p.m. So by 2 p.m. By 2 p.m. the matatu was at this particular point, and I mean that is the motorist, and then the matatu was at point A. That was by 2 p.m. So by 2 p.m. and you know that the motorist had cover a distance of 40 kilometers. So to get the time distance from A where the matatu met, so they must be able to meet at a certain point. So, and to get a time taken to meet is given by the distance between the two vehicles, distance between them, and also we get the relative speed. So by 2 p.m. the distance between them was 40 kilometers, as we have got in part Roman 1 of part A. And then the relative speed, since they are moving in the same direction, we get the difference in speed. So 80 minus 60. 80 minus 60 kilometer per hour. So we end up getting 40 kilometer divided by 20 kilometer per hour. So this will be 2 hours. So from 2 p.m. they will meet after 2 hours. So they will meet after 2 hours. And therefore the distance from town A in kilometer. So to get the distance from town A in kilometer, now we are considering matatu left from town A up to the point where they met. So the distance from A when they met will be speed times time. And in our case here, it's after 2 hours. So matatu left from town A at a point where they meet. What is the distance covered? So speed of the matatu is 80 km per hour. We multiply by time after 2 hours. That's when they met. So this will be 160 km. So from town A. So they'll meet 160 km from town A. Move on. Part A, Roman 3, time when the matatu caught up with the motorcyclist. The time when the matatu caught up with the motorcyclist. So we have seen that the time after 2 hours, that is when the matatu was able to overtake caught up the motorcyclist. So from 2 p.m. So after 2 hours, we add 2 hours. We are going to get, that will be 4 p.m. or in 24 hours clock system will be 1600 hours. Then part B of the question, a lorry traveling at an average speed of 40 km per hour left town B for town A at 2 p.m. Determine the time when the lorry and the matatu met. So still from town A to town B, so a lorry traveling at an average speed of 40 km left town B. So the lorry left town B towards A and the speed was 40 km per hour, and that was at 2 a.m. And then determine the time when the lorry and matatu met. And matatu left town A. Matatu left town A at 2 p.m. and it was traveling toward B, and that was the speed was 80 km/h at 2 p.m. So they left at the same time. They actually left at the same time. So we need to know the time it took for them to meet, the time it took for them to meet. And the distance from A to B is 400 kilometers. So time taken to meet is distance between them, distance between A and B, all over relative speed. So distance between A and B is 400 kilometers, and the relative speed, since they are moving in opposite direction, we are going to add the speed. That will be 80 plus 40. Therefore we have 400 divided by 120. So this will end up getting that will be 3 hours and 20 minutes. But the question is, determine the time when the lorry and the matatu met. So from 2 p.m. after 3 hours 20 minutes, that is when they met. So we add, so by 5:20 p.m. that's when they met, or in 24 hours clock system will be 1720 hours. On the following grid, triangle PQR is drawn. Here is the triangle already drawn with the scale given. Therefore, but on the same grid we need to draw triangle P prime Q prime R prime, the image of triangle PQR under reflection in the line y is equals to 0. So what we need to know here, while the line y is equal to 0, that is actually the x-axis. Y is equals to 0 is normally the x-axis, and therefore we need to locate PQ, P prime, Q prime, R prime. So that means P, which is, okay, so here P is 1, 2, and then Q is 2, 1, and R is 2, 2. So it is mapped to P prime, Q prime, and R prime. So now this triangle, when reflected in the line y is equals to 0, that is the x-axis. Remember properties of reflection. The image distance is equal to object distance, and they are perpendicular to the line, mirror line. So from here, Q prime will be at this particular point. It will be Q prime. Then R prime will be R prime, and then P prime will be at this point, P prime. Therefore, we can be able to join the point together. So joining the points P to R, and then R to Q, P prime, and P prime to Q prime. So that is that is a triangle P prime, Q prime, R prime, and this is the mirror line. So this is our mirror line. Then the other Roman 2 triangle P prime, Q prime, R prime, the image of P prime, Q prime, R prime under an enlargement scale factor. So under an enlargement scale factor, this scale factor is minus 1.5. Actually it is given, and the center is 0. So the center is about the origin. So we need to get P prime. So to get P prime, actually it will be the scale factor times the coordinates of P prime. So that will be minus 1.5 times the coordinates of P prime, that is 1 minus 2, 1 minus 2, Q prime is 2.2 minus 1, and the other one is 2 minus 2, 2 minus 2. So multiply by 1 minus 2, so we shall get, that will be minus 1.5 and 3. So that will be the coordinate of P prime. For Q double prime will be minus 1.5 times the coordinates of Q prime, 2 minus 1. So we end up getting the coordinates will be minus 3 and then 1.5. And lastly, R double prime will be the scale factor of minus 1.5 times R prime is 2 minus 2, so the coordinates will be minus 3 and 3, minus 3, 3. So since we have the coordinates of P prime, Q prime and R prime, now we can be able to plot the points. So let us plot the points. So P double prime is minus 1.53, minus 1.53. So that's where P double prime is. Then Q double prime minus 3, 1.5. So that is the point. Minus 3, 1.5, that is Q double prime. And finally R double prime is minus 3, 3. So that is it. Therefore we join the points. So this is R double prime. So let us join Q double prime to R double prime, R double prime to P double prime, then P double prime to Q double prime. So that is the triangle under the enlargement. So the image of what? The image of is triangle under that enlargement. So the center, origin, that is what we have. So that is it. So P point to P prime, then Q prime to Q double prime, and then R double prime to r double prime. So you can be able to see this is the center of enlargement. Then triangle P triple prime Q triple prime R triple prime, the image of triangle P double prime Q double prime R double prime under a half turn about the origin. So there is half turn or a rotation of 180 degrees about the origin. So in such a case, then P triple prime, so we have P double prime, so actually the image of, so this is a triangle, the image, so which is, this is minus 1.53, it is mapped onto to P triple prime. So in that case, and since it is half turn rotation about the origin, then we should be able to get, actually they are going to interchange these values. Actually they will interchange the signs. Actually the signs is what will just be interchanged. So this will be 1.5, the other one will be minus 3. The other one is Q double prime triple prime will be 3 minus 1.5, and then R triple prime will be 3 minus 3. I hope that is clear. So we can be able to plot those points. So let us be able to plot these points. So the first one is P triple prime, that is 1.5 minus 3 there. Then Q triple prime 3 minus 1.5, and the other one is R triple prime, that is 3 minus 3. So that's the point. Therefore we join. So before we join, this is P triple prime, Q triple prime, and R triple prime. So we join those points. So that's how it will be. Fine. So that's how it will be. The other thing now is to describe a single transformation that maps this triangle P prime Q prime R prime onto P triple prime Q triple prime R triple prime. So from there, now join P prime to Q P double prime. So there is something you'll notice. So if we join them, they are meeting at a certain point, and that is the origin. That means there is an enlargement. It has enlargement, and the center is about the origin. So for us to describe it, we have to give the scale factor and also the center of enlargement as required. So in that case, so to get the scale factor, it will be either image distance, image distance over object distance. So in this case, this is our O, center of enlargement. So OP triple prime divided by OP double prime, I mean single prime, will be equal to, so change in the in our case here, this will be minus 3 change in Y. So we take that 3 minus 3, and then in the x direction it has actually moved, that is minus. So that's what you need to consider. Either you are dealing with the x coordinate or y coordinate, you still get the same. So OP double prime y direction minus 3, for P prime is minus 2, so we get 1.5. So you can also try with OQ triple prime over OQ prime, and the rest will get 1.5. So this actually enlargement scale factor is 1.5 about the origin. So the center origin, the center is 0, 0. So that's how we do this particular question. So thank you so much for paying attention. Question 19. The following figure shows a right pyramid VABCD. The base ABCD of the pyramid is a square of side 8 cm. The length of the slanting edges VA is equal to VB is equal to VC is equal to VD, which is 10 cm. So calculate part A, the vertical height of the pyramid, correct to 2 decimal places. Part B, surface area of the pyramid. And part C, the volume of the pyramid. So for part A, we need to find the vertical height of the pyramid, correct to 2 decimal places. So to get the vertical height, so I need to join the diagonals of the base A to C and also B to D, such that they meet at 90 degrees. Then I draw the perpendicular height or the vertical height. So let the diagonal meet at point O. Now let me just extract from this. I have now I have point O, then I have C, and then V. So VC is 10 cm. Then we need to find the vertical height, and then OC will be a half of AC. But to get AC at this particular point, at B it is 90, so we can use Pythagoras theorem to get AC, then we get OC. So AC will be given by the square root of AB squared plus BC squared, which is square root of AB is 8 squared plus 8 squared. So we shall end up getting the square root of 128. 64 plus 64, that is 128. Using a calculator, get 11.31 centimeter. So we need OC. OC is a half of AC, and already we have AC, so that is a half of 11.31. So we are going to get 5.66 5 centimeter. That's for significant figure. Then now to get, so OC is 5.655 centimeter. So to get now OV, which is equal to H, will be square root of VC squared minus OC squared, and this will be square root of VC is 10, we square it, minus 5.655. We also do the squaring. So to be squared. So using a calculator, so you get this will be square root of 68.02, and therefore the square root of 68.02 will be 8.25, correct to 2 decimal places. Then part B of the question, calculate the surface area of the pyramid. So we need to get the surface area of the pyramid. In that case, whatever we need the area of the base, A, B, C, D, and then the areas of the slant faces. So base area is length by length, which is 8 times 8, we get 64 centimeters squared. Then we need the slant height to get, because the base is a square, that means all faces are equal. So we get the area of one face and then we multiply it by 4. So in that case, so if this is the one face, B, C, V, so that's the face I've chosen. I need to get this slant height of the triangle. So that's slant height of the triangle. This is 8 centimeters, so it's 4, and this is 10. So I can use Pythagoras theorem and I'll be able to get it. So 4. So to get, let me say this is M. So Vm will be equal to the square root of 10 squared minus, that is 4 squared. We shall end up getting, so 100 minus 16, that is 84. So the square root of 84 is 9.165 centimeter, and therefore area of one triangle will be a half base times height. Base is 8, then times height is 9.165. So we end up getting, that will be times 8 times 9.165, we get 36.66 centimeter squared. So area of 4 faces, 4 triangles, will be 36.66 times 4, which is 146.64 centimeters squared. Therefore, total surface area will be equal to area of base 64 plus the area of the 4 faces 146.64, then plus 64, that will add up to 210.64 centimeter squared. Then part C of the question, we need to find the volume of the pyramid. So volume is given by a half times base, a third times base area times the height, and that we mean perpendicular height. So we have a third. The base area, remember it's a square base, so 8 times 8. Then the perpendicular height, we got it as, in part A, we got it as 8.25. Therefore, if you use a calculator, multiply, we get 176 centimeter cube. Question number 20. Nema went to the market to buy bananas worth 2,100 shillings for school. The seller offered a discount of 3 shillings per banana, which enabled Nema to buy 5 more bananas. Part A of the question. Taking X shillings as the price per banana before discount, write an expression for Roman 1. Number of bananas that Nema would have bought before discount. Roman 2. Actual number of bananas that Nema bought after the discount. Part B. Form an equation in terms of X and hence determine the actual number of bananas Nema bought. Part C. The bananas were given to students in a school. 2/5 of the students got 2 bananas each, while the rest got a banana each. Determine the number of students in the school. So, we need to answer part A of the question. So, if Nema went to the market and bought bananas worth a total of 2,100 shillings, and the seller offered discount of 3 shillings per banana, which enabled Nema to buy 35 more bananas. So, we take X as the price per banana before discount. So, we need to write an expression for part 1. The number of bananas that Nema bought before discount. So, the original number of bananas, that is before discount. So it will be the total amount divided by the price per banana. The total amount was 2,100 shillings, and the price per banana before the discount, it was X shillings. So, taking before discount, X shillings. So, that is the expression for number of bananas before discount. Then Roman 2, actual number of bananas that Nema bought after discount. So, price after discount will be X minus 3. That will be X minus 3. So, number of bananas after discount. So, it will be still the total amount, which is 2,100 divided by the price after discount. Or can also be the other case. So remember, original number of bananas was 2100 over X. So the number of bananas after discount. So remember, she bought 5 more bananas. So will be the same as the original number of bananas, so which is 2100 over X plus 35. Either of these will be accepted. So those are the expression. We can move on to part B of the question. So part B of the question is Nema went to the market and still form an equation in terms of X and hence determine the actual number of bananas Nema bought. So we needed to remember back from what we have done in part A, Roman 1 and 2. The original numbers of banana is 2100 over X. and the actual number of banana after discount is this amount, and this is what we are going to use in our second calculation. So the original minus this is the price after number of banana after discount is more by 35 the original, so that will be 2100 over x minus, that is the number of banana after discount, which is 35 more than the original number of banana, which is 2100 over x. If you subtract the two, it will be fine. Remember, it was 35 more bananas were bought. So from here, LCM of x and x minus 3, that is the LCM, is x minus 3. So we pre-multiply each term by the LCM. If we multiply this term by the LCM, we are going to get 2100 times x minus 3 will cancel, then minus the other one, x and x will cancel, so we have 2100 times x minus 3 will be equal to 35 times x minus 3. So you just open the bracket, so this will be 2100x minus, open the bracket, 2100x, negative this times negative this, plus 6300 will be equal to, open the bracket, that 5x squared minus that 5x times minus 3, that is 105x. So from here, this and this will be eliminated. So we have now 35x squared minus 105x minus 6300 is equals to 0. I'll just rearrange them. So I can simplify, divide it through by 35. So this will be x squared minus 3x. This will be minus 180 will be equal to 0. So I need to solve for x, and I'm going to use factorization method because it is easier to use it. So product of AC, so the product is, so the factors is 1 times minus 80 or minus 80. So I get factors of minus 180, such that when I add them I'll get minus 3. So, and in that case the factors will be minus 15 and 12. If I try to add minus 15 plus 12, I'll get minus 3. So I'm going to rewrite this quadratic equation, but the middle term being expanded, the expanded form. So this will be x squared minus 15x plus 12x minus 180 is equal to 0. Then I take into pairs, and then I factor out what is common. In that case, the first part, x is common, so I factor x out. Then I'll have x minus 15. Then the second part, 12 is common, so plus 12. So 12x divided by 12, I get x. Then minus 180 divided by 12, I get minus 15. Will be equal to 0. So this will be x plus 12 multiplied by x minus 15 is equal to 0. So either x plus 12 is equal to 0 or x minus 15 is equal to 0. Therefore, x is equal to minus 12 or 15. number will be, x will be 15. X will be 15. So the question is, we solve, find in terms of x, hence determine the actual number of bananas Nema bought. So the number of bananas, so x is 15. So the actual number of bananas that Nema bought, number of bananas, actual, that is before discount, be 2100 over x, and that is 2100 over 15. Therefore, we end up getting, we have 140, then 140 after the discount, actual number, so after the discount he was able to buy 35 more since he was given discount, so plus 35, so we end up getting 175 bananas. Then we go to part C of the question 2020. The banana were given to students in a school. 2/5 of the students got 2 bananas each, while the rest got a banana each. Determine the number of students in the school. So since we don't know the number of students, we can say let the number of students be n. So if the number of students are n, therefore it means 2/5 of the student got 2 bananas each. So 2/5 of the student n got 2 bananas each. So times 2, the number of bananas each got, then plus the remaining fraction, which is 3/5, got, each of them got 1 banana. So 3/5 of the students times 1 banana each got. And remember, the total number of bananas we got was 175. 175, the total number of banana original after the discount, that is 175. Therefore we work it out. This will be 4/5n plus 3/5n is equal to 175. So 4/5 plus 3/5, that is 7/5. N will be equal to 175. So n will be 175 times 5 divided by 7. So you should end up getting 125. Therefore it means the number of students in that school, there were 125 students. Question 21. The end of term test scores of 100 students were recorded as shown in the following table. That is the scores, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and their corresponding number of students in each course. Then part A of the question, we need to state the model class. Part B, calculate the median score. Then part C, on the grid provided, we represent the above data. Using a histogram, and then use the histogram to determine the number of students who scored from 71.5 to 76.5. So we state the model class. So model class is the most repeated class, That means the class with the highest frequency. So in our case, if you look, the one with the most number of students is 32, but the class is 60 to 69. So that is the model score. Most of the students were able to score between 60 and 69, the model class. Part B, we calculate the median score. For us to be able to calculate the median score, so we need to get the median position, and we get median position is normally a half of n, or n over 2, but there are how many number of students? There are actually 100, so that will be 100 over 2, which is 50th position. 50th position. So that is the position of the median position. Then, using the formula, median is given by the lowest boundary, class boundary, plus n over 2 minus cumulative frequency, the median class, divided by frequency in the median class. This is cumulative frequency preceding the median class, then times the class interval. So for our case here, first we need to indicate cumulative frequency. We can have a row, and we get the cumulative frequency by adding the corresponding frequency, that is the number of students. We have 8, then 8 plus 10, that is 18, 18 plus 28, that is 46, 46 plus 32 gets 78, 78 plus 12, that's 90, then 90 plus 10, that is 100, must be equal to the total number of students. Then lower class boundary, so we need to identify the median position. So the position whereby we have 50, so 46, 50 is not included, so where we have 78, so this is the median class. This is the median class, 60 to 69, and therefore lower class boundary, the median class between 59 and 60, so it is 59.5, then plus 100 over 2, that is 50, minus cumulative frequency preceding the median class, it is 46, comes before the median class, then divide by frequency of the median class, which is 32, then times the class interval. So you get class interval 40 minus 30, or 50 minus 40, that way we get 10. So this will be 59.5 plus 50 minus 46, that is 4 over 32 times 10. So we end up getting 60.75. So that is the median score. Then we move on to part C. On the grid provided, represent the above data using a histogram. So for histogram, we normally plot frequency against the upper class boundary, and for the upper class boundary, in our case here, it will be 39.5, 49.5, 59.5, 69.5, 79.5, then 89.5. And frequency, we're going to use 8, 10, 28, 32, 12, 10. So the maximum is 32. And so if we draw and it reaches 40, no problem, it will be alright. So just take the ruler and then we draw also draw the y-axis. Now from here 0, so for the y-axis can use 2 big square to represent 10. So 10, 20, 30, 40. That is the frequency, or in other words, number of students. Then the x-axis, since we have the scores from 30 to 39, we use the upper class boundary, so we have 39.5, but the previous one was 29.5. so even without breaking, we can say let our y-axis to start from 29.5, but if you also break the axis, there is no problem. So 29.5, then 39.5, then 49.5, then 59.5, then 69.5, then 79.5, and lastly 89.5. So that is okay. Remember the reason why in the first part you have 29.5, and you can see here we have 30, so the previous upper class boundary was 29.5, and that's why we have it here. So this is upper class boundary. That's so important. Then the other thing is, now we need it to plot. So between 29.5 and 39.5, the number of students, now the frequency is 8, and one small square represents 1 student. So from here we can see the first one is 8, so we have 8 from here, 8. Then the other one, 39.5 to 49.5, it is 10. So draw the histogram there. That is clear. Then from 49.5 to 59.5, it is 28. So from here our 28 will be at that point. Then from 59.5 to 69.5, frequency is 32, so 32 will be at that point. Then 69.5 to 79.5 is 12, so at 12 this particular point. Then lastly 79.5 to 89.5 is 10. Now that is okay. So this is the histogram we have drawn for the above data represented. So we can move to next part which is part D. Part D. Use the histogram to determine the number of students who scored from 71.5 to 76.5. So we want to see from 71.5 to 76 is between 69.5 and 69.5 and 79.5. So in other words, the number of students, will be equal to the class width divided by, so since we have a uniform class interval, so divided by the class interval, then times the number of frequency in that particular rectangle bar. So the difference class width is 76.5 minus 71.5 divided by the class interval. I've seen the class interval is 10, 10. So times the frequency in that particular bar, the frequency is 12. So 76.5 minus 71.5, we get 5. So over 10 times 12. So we end up getting 6 students. So the number of students who scored between 71.5 to 76.5 is 6 students. Question 22. The following figure shows a quadrilateral PQRS and a circle passing through the vertices PR and S. Lines PQ is equal to PR is equal to 2.7 centimeter. PS is equal to 6 centimeter and SR is equal to 7 centimeter, and angle PQR is equal to 65 degrees. So you need to calculate length QR need to get length QR, then angle PRS, we need this angle, also required, and then determine the area of the circle. We need to determine the area of the circle. So let us begin with this part, QR, triangle PQR, so that we get length QR. We are going to use the sine rule. So let me consider this side QR is opposite vertex P, so let me use this is small p, and then we have R, this will be small r opposite to vertex R, and this Q opposite to vertex Q. So using the sine rule, we need to find length QR. We already know this angle 65. Also the other angle will be 65. Remember PQ and PR are equal, so this will be 65 degrees. Therefore, this angle here will be 50. So 65 plus 65, that's 130. 180 minus 130, 50. So P over sine P. So P is the side. P over angle sine P, angle P will be equal to, so any other value that is known, we have angle at Q, so on this side, so Q side Q over sine Q. So P, we don't know P, and that's what we have after. So P will be given by Q over sine Q times sine P. Therefore, P which is equal to QR, will be given by, so Q, set Q is 2.7 all over sine Q, Q is 65 degrees, so sine 65 degrees times sine P, P is 50 degrees, so sine 50 degrees. So this will be 2.7 times sine 65. Using a calculator, you get 0.9063. Then times sine 50 using a calculator is 0.7660. Therefore, if you are out using a calculator, you get 2.282 centimeter. Going to for significant figure, to once one decimal place will be 2.3, and that is the length of QR. Then we move on to part A, Roman 2. We get angle PRS. PRS, this angle. That's what we require. So we are going to use cosine rule, and therefore from here, so since this side is opposite vertex R, we call it small r, is equal to 6 centimeter. Then this side is opposite vertex P, so P is equal to 7 centimeter. And then S is vertex X, PR is opposite vertex X, so this will be S is equal to 2.7. So I hope that is clear. So in that case, whatever we are looking for, angle R, that's what we are looking for. Therefore, we have side R squared will be given by, will be equal to the other two sides, the square of the other two sides. So P squared plus S squared, then minus 2PS cosine the angle that is to be found R. So R, we know it is 6, so that will be 6 squared times P. P is 7, so 7 squared plus S is 2.7, we square it, then minus 2 P times P is 7 times S is 2.7 cosine R. Therefore, so this is 36, will be equal to 49 plus 2.7 squared, that is 7.29 minus, so 7 times 2 times 2.7, that is 37.8 cosine R. So we move on. So from there, we have 36 is equal to 49 plus 7.29, that is 56.29 minus 37.8 cosine R. Therefore, subtract 56.29 on both sides. That will be 36 minus 56.29, which will be minus 20.29 will be equal to minus 37.8 cosine R. Divide both sides by minus 37.8. So that will be cosine R will be equal to minus 20.29 divided by minus 37.8, which is equal to 0.5368. Therefore, R will be cosine inverse of 0.5368. Therefore, we shall get angle PRS, which is equal to angle R, is 57.53 degrees. Then the last part is to determine the area of the circle. Determine the area of the circle. So, before even we get to the area of the circle, then we are required to find the radius. We need to know the radius of the circle. But how can we be able to get the radius of the circle? How? So that is something important we need to know or get. So if that is the case, then we are going to use the sine rule, which will help us to get to the radius of the circle. So for sine rule, we know that from here we can have this side PS. We also have SR, whichever will be much applicable with the corresponding angle. So in our case, we can be able to deal with R So we know the angle R, and then this side is opposite it. So remember that for sine R over sine to R will be equal to 2R, whereby R is the radius of the circle. Radius of the circle. Even if we try with S, in our case with S also, we'll still have to get the same result. But whatever we have, we can easily deal with this since we have the angle R. So sine R, so I mean this will be R, not sine R, that will be R. Side R is the side R will be opposite angle R. Therefore, R, which is side PS, 6 over sine R, previously we got as 57.53 will be equal to 2R, where R is the radius of the circle if circle was to be drawn on it. Then therefore R will be equal to 6 over 2 sine 57.53, and this we end up getting 3.556 centimeter. Therefore, to get the area of circle, which is pi r squared, so we shall get over 7 times the radius 3.556 squared. So we end up getting 39.74 centimeter squared. So that is the area of the circle. Question 23. The displacement x meters of a particle moving along straight line after t seconds is given by x is equal to t raised to 3 over 3 minus 3t squared plus 9. Part of the question, determine Roman 1 the values of t when the particle is momentarily at rest. Roman 2 of part A, the values of the displacement x meters by the time the particle comes to rest. Then part B of the question, determine the values of t when the velocity of the particle is minus 5 meters per second. Then part C, determine the acceleration of the particle at t is equal to seconds. Therefore, if the displacement of a particle is x meters from moving along a straight line t seconds, so it's given by, so displacement x is equal to t cubed over 3 minus 3t squared plus 9. So what we need to know that when the particle is momentarily at rest, then at rest the gradient function, that is of displacement, differentiation of displacement with respect to time, is given by, is actually equal 0 at rest. It is 0, or we say at the turning point, that's at the maximum height. So dx dt will be given by, we differentiate what we have. So if we differentiate this, it will be 3. So we have t raised to 3 over 3. So when differentiating, we multiply by the power, and then we reduce the power by 1, then minus the other one, we have 3t squared, so we multiply by the power, so times 2, and then we reduce the power by 1, and lastly then you have plus, so 9, this is the same as x raised to 0, so that will be 0 times 9, then x raised to 0 minus 1. So everything multiplied by 0 is 0. So therefore we are going to have, this will cancel, so we have t raised to 2. Then the other one will be minus, so 2 times 3 minus 6, t raised to 1. The other one is 0. So that is a gradient function. And they are saying that at rest, the gradient function is equal to 0. Therefore, this will be equal to 0. So we can factor out t. So we have t minus 6 will be equal to 0. Either t is equal to 0 or 6. So from the starting point, so after 6 seconds, the particle, after t is equal to 6 seconds, because the initial starting point t was 0, so after 6 seconds, then the particle will be momentarily at rest. Then Roman 2 of the question, the values of the displacement x meters by the time the particle comes to rest. So displacement, so after when t is equal to 0, because that is when the particle is at rest, so when t is equal to 0, displacement x, we substitute into the equation of displacement. So when t is 0, so that is 0 cubed over 3 minus 3 times 0, so that is 9 meters. And when t is equal to 6 seconds, so the displacement will be 6 cubed over 3 minus 3 times 6 squared plus 9, so this will be 72 minus 108 plus 9, whereby we get minus 27 meters. So that is in the opposite direction. Remember, displacement is a vector quantity, so it is in the opposite direction. Then part B of the question, determine the values of t when the velocity of the particle is minus 5 meters per second. Remember, for displacement, displacement, we have that is t cubed over 3 minus 3t squared plus 9, and therefore dx dt, we got it as t squared minus 6t. So displacement, and this is actually the velocity. So when dx dt is minus 5, so t squared minus 6t is equal to minus 5. So this is the same as t squared minus 6t plus 5 is equal to 0. I'm going to use factorization method to solve for this quadratic equation. So the product AC 1 times 5, that is 5. Then I look for factors of 5 such that when I add them I'll get minus 6, and the factors I have minus 5 and minus 1. So I write the middle part or term in the expanded form. That will be t squared minus 5t minus t plus 5 is equal to 0. Therefore I take into pairs and I factor out what's common. So in the first part t is common, so factor out, I get t into bracket t minus 5. Then the other part 1 is common, so I get t minus 5 is equals to 0. Therefore this will be t minus 1 multiplied by t minus 5 is equal to 0. Therefore t is equal to 1 or 5. So when the particle is minus 5 meters per second, it's after 1 second or 5 seconds. And then lastly, part C of that question 23, determine the acceleration of the particle at t is equal to 2 seconds. Acceleration of the particle, we have to differentiate velocity. So remember, acceleration is given by dv dt. But remember, we had dx dt, which was t squared minus 6t. So actually now this we need to differentiate it, differentiate it again so that we get this value. So dv dt, so need to get to differentiate this again, and I will get this will be 2t minus 6. Therefore at t is equal to 2 seconds, 2 times t is 2 minus 6. So this will be 4 minus 6, which is minus 2 meters per second squared. And that is the acceleration of the particle at t is equal to 2 seconds. So question 24. In this question, use a ruler and a pair of compasses only. So we expect to use a ruler and also pair of compasses only. So line PR, so this is actually PR, not Q. So PR is 6 centimeter. So we are required to locate PR is diagonal of a quadrilateral PQR, yes, and PR is 6 centimeter. Then we are required to locate vertex Q of the quadrilateral PQRS such that angle RPQ Q is 60, so we are going to draw an angle of 60 degrees at P, and then angle PRQ at this point also we draw an angle 45 degrees. Then we complete triangle PQR and ends measure PQ. Then part B, diagonal QS, which is 10 centimeter, intersect with diagonal PR at right angle. Complete the quadrilateral PQRS. Then calculate the area of the quadrilateral PQRS. So from here, what we are required, so already we have been given the length PR, which is 6 centimeter. So we need to construct an angle of 60 degrees at P. So we use a compass. So we have a compass here, and that's what we are going to use so that we actually plot an angle or construct an angle of 60 degrees. So in that case, I'll just adjust the length of the compass, the radius. So I use, and then I put a mark. Then from there, I also move the point of the compass to this side, and then I also maintain the same radius and put an arc there. So once I do that, I am going to use a ruler to join the point P and the intersection of the axis. So in that case, so let me use this. I join the points, point P and the intersection of the axis. So once I join, so let me join. So I have joined that point. Then, so this angle is, 60 degrees. Then at R also, I'm going to construct 90 degrees first, then from there bisect it to construct an angle of 45 degrees. So in that case, it will allow me just to extend this PR at R. So I extend it outwards. Then from there, I'll be able now to construct a perpendicular angle, or an angle of 90 degrees. So for I to construct an angle of 90 degrees, I required to make an arc this side, and also on the other side I put an arc. Then from there, now I'll use the pointer at this point. The arc I've just made, then I put an arc at the top and also below, maintaining the same radius. I place the pointer of the compass at that particular point. Then I also put an arc at the top and also at the bottom. Then I take a ruler and then I draw that vertical or the perpendicular line. So to the perpendicular line, that point. Once I do that, I take the compass again, and then I now bisect the angle. Now I bisect the angle. First I put those two marks there, and then I adjust the radius and use the arc that I have made on line PR and the perpendicular. So just adjust it. I make an arc there, and also I use the other side as this center, the radius. I put an arc there. Once I do that, I take the ruler. So I'm going to construct or draw the line so that it joins. So that is the point where they intersect, that is the point. The other point, Q, it will be Q. So this will be point Q. So this angle we have drawn, constructed, is 45 degrees. Then from there, we have located the vertex Q such that this angle is 60 degrees and this one is 45 degrees. So the other thing is, we have been told diagonal QS, which is 10 centimeter long, intersect diagonal PR at right angle. Therefore, we are required to, it's perpendicular, so it cut PR at right angle. Therefore, we need from Q, we are going to draw a perpendicular line downwards. So if we do that, so from Q, I mean, we draw perpendicular. So from there, you can plot the perpendicular line. So from here, I draw that line first. Then after that, I put an arc down there. From what I just maintaining, I can still try to maintain the same radius, or I just adjust it. There's no problem. So using this as the center, the arc, I draw an arc there. Also, the other arc side, I use it as the center, and I draw the arc at that particular point. Then once I do that, I take a ruler and join, draw that line from Q downwards. And since QS is 10 centimeter, therefore I'm going to measure from Q a length of 10, and then I put the arc 10 centimeter. So that is 10 centimeter. So that's where it is, and that is S. Therefore, from there, now I'll join RS. I'm going to join RS. So you join RS. And then P to S. Once I do that, now Another thing that we need just to consider is to answer the question as required. Part A, we actually located the vertex Q, and afterwards we complete triangle PQR, and hence we find length PQ. So what will be length PQ? PQ will be what? So length PQ, just take the bus and let us measure it and see the value you are going to get. So I'm getting 4.4, that is 4.4 centimeter. Then the other value we are going to get, QS was actually 10 centimeters, that's why I've just written it there. So that is PQ, and then we have completed the quadrilateral and it can be seen. Then calculate the area of quadrilateral PQRS area. So for the area, it will be area of triangle. We can just subdivide them into two triangles such that PQS plus area of triangle QSR. So that is in order. So the only thing we need to know from the perpendicular bisector QS, let us say it is meeting cutting at M. So PM will be what? So value of PM and also the value of MR will be what? So from here, I want to measure Q, so that will be 2.2, that is 2.2 centimeter, and then MR will be 3.8 centimeters, such that in total it will be 6 centimeters. So the area will be a half. Base for this triangle, the base is 10, then height is 2.2, and then plus the other one is a half times base is 10 times the height from M to R, which is 3.8 centimeter. So for this one, this will be 11 plus the other one will be 19. So if we add, we get 30 centimeter squared.